access control list, ACLs are an essential part of a well-designed and maintained network. They provide an essential piece of the puzzle to control traffic and port data. ACL provide packet filtering and can be implemented on router, multi-layer switches, and firewalls. ACLs are used to define interesting traffic and can be used for a variety of purposes, including security, traffic direction, and QoS. ACL can be used as a part of a mechanism to permit, deny, classify, and mark traffic to secure, optimize, and protect the network. QoS can be implemented by using Cisco Modular QoS Configuration (MQC), which include class map to define the traffic, policy map to apply the rule, and service policies to activate them on an interface. ACL serve as packet filter and can be implemented at various points in the network. On perimeter routers, it is common to implement an ACL that filter out known problem traffic, such as traffic sourced from a private address space that doesn't belong on the internet. On the interior router or layer 3 switches, ACLs can be implemented for security and QoS purpose. They can permit or deny traffic going through the device to and from certain destination and application. The ACL can be implemented as standard ACLs, which only filter on source address, whereas extended ACL can filter on source and destination addresses, as well as source and destination application and protocols. Named ACL make use of descriptive names such as block HTTP, which make it easier to remember the purpose of the filter. It is important to remember that ACLs are only one aspect of the security, and they are only part of the overall solution and architecture of the network. An example of how ACLs can be implemented to think about a connection between web server and a data server. The web server might reside on a DMZ, which is an area that has a lesser security level than an internal network. The database server would reside on the internal network and therefore have a higher security level. ACLs could be implemented to only allow access from certain web server and specific application on the database server to decrease the vulnerability footprint. Another example of ACLs could be implemented for QoS purposes when dealing with latency sensitive traffic such as voice and video. In the case of voice traffic, we would mark it at the edge of the network and then mark it with an ACL and place it into a priority queue. The voice traffic in the priority queue would be serviced before any other traffic, and only when the priority queue was empty would traffic in the other queue be serviced. Through this mechanism, we ensure that the voice traffic is the highest priority and service available on the network. Special care should be taken when creating and implementing ACLs because they can sometimes have unintended consequences. If not implemented correctly and tested thoroughly, ACLs stretch traffic in a top-down manner in which the order of the rule in the ACLs become very important. When the ACL is implemented, the traffic will be tested again against each statement in order until a match is made to either permit or deny. If no matches entry is found in the ACL, then there is an implicit deny any which is invisible but at the end of each and every access list. Testing of ACLs should be done in a lab environment if possible. Then the ACL should be moved to the production during off hours or during a change management window. Finally, a comprehensive checklist of before and after the ACLs implement should be completed along with a contingency plan for back out or reversal if things don't go as expected. Thank you.